Hello everyone. In this video we'll talk about functions. And a function is actually a relation that associates each element x of the domain of the function to a single element y, the range of the function. And we can tell whether a graph represents a function or not by trying the vertical line test, in which we are going to draw a vertical line passing through the graph, and it has to intersect the graph in at most one point. So in this question here, we are going to try to find out whether the graph represents a function or not. So what we are going to do, we are going to draw a vertical line. So I'm going to try to draw a vertical line passing through the graph. You can try it here. You can draw another one here. It's totally up to you. Okay. Now we are going to look at this line. What happened here basically? We will notice that the vertical line intersects the graph at 2 points. So this is not a function. Based on the vertical line test, this cannot represent a function because the line is basically intersects with the graph in more than 1 point. Let's try this one here. So in this case here, I would like to do the same. I'm going to try the vertical line test. I'm going to draw a line here, vertical line, and I'm going to test that. I notice that the line that I drew intersects with the graph at 1 point only. So this graph represents a function. One more question here. What about this one? Well, again, I'm going to draw a vertical line and I will start to look at how many points did the vertical line intersects with my graph. And I notice that it's at 1 point. Next, we are going to learn some very important characteristics about a function graph. We're going to look at we are going to try to find out the x-intercepts, y-intercepts, positive intervals, negative intervals, the intervals of increase, the intervals of decrease, the domain, and the range of the function. So we'll start with the x-intercepts. What do we know about x-intercepts? Well, x-intercepts are the points at which y equal to 0. By looking at the graph, it's basically the points at which the function intersects with the x-axis. We're talking about this point here, we're talking about this point here, we're talking about this point here. These are the x-intercepts. You can write them as an ordered pairs, or you can write them as x. I'm going to start from the lowest one. So I'm going to say x equal -5, x equal -1, and x equal 3. You can do it this way, or you can say, -5 and 0, which is as an ordered pairs, -1 and 0, and 3 and 0. Okay, it's up to you. Let's look at the y-intercept now. Y-intercept is basically the point at which the graph intersects with the y-axis. We're talking about this point here, right? So this point here is 10. It's y equal 10. Or you can say at x equal to 0, so 0, 10. That's the ordered pairs. Now we are going to talk about a positive and negative intervals. So a positive interval is the part of the graph above the x-axis, in which it has a corresponding positive y value. So everything above the x-axis has a positive y value. Everything below the x-axis has a negative y value. So whatever below the x-axis is negative interval. So how we are going to say it? If you notice that the function here, okay, I'm gonna take it this part here. Function here is going down, and here is going up. There's an arrow, so don't forget that. It goes to negative infinity, y, negative infinity from x. Here, positive infinity goes all the way up, increasing, and here increasing for y. So how we are going to write the intervals? Well, I can see that I only have one part of x that is below the x-axis, which is this part that goes all the way down. So it's basically, if I want to read it from x, I'm going to say it goes from negative infinity, that's negative infinity, all the way to 5. Okay? What about at 5? Well, at the point 5 and negative 1 and 3, y was 0. Right? So it's not positive, it's not negative. 0 is a neutral number. So I can say negative from, as an interval, okay? We are looking at intervals here. From negative infinity all the way to negative 5. And I'm going to keep it open. I'm not going to include negative 5 because when x equals negative 5, y is 0. Now let's continue. Then from negative 5 all the way, someone will say from negative 5 all the way to positive infinity, it was positive. No, no, no. Because I do have some points where y was 0, not negative. So I need to break it down. I'm going to say from negative 5 all the way to negative 1, open from both sides, it was positive. Union or comma, it's up to you. From negative 1 to 3, it's positive. And from 3 all the way up, it's positive. Or sorry, to the right, my bad, to the right. All the way to infinity is positive. So one more time, from negative infinity all the way to negative 5, the function was going down, decreasing. So it was below the x-axis, that's negative. Negative 1, negative infinity all the way to negative 5. I left it open because at these points where x was, the x-intercepts points, y was 0. So it's not negative. We cannot include it. Same with the positive interval. So from negative 5 all the way to negative 1, it was above the x-axis. Negative 1 to 3, above the x-axis. 3 and positive infinity above the x-axis. So that's regarding the positive and negative intervals. Now we are going to study increasing and decreasing intervals. In order to study the increasing and decreasing, you need to start from the left side. Remember again that the graph here is going all the way down. Don't forget this part because otherwise, oh my God. I'm just going to draw it here. Okay. Function was going down, okay. So let's start from the left side. We are going to track the function. So I'm going to go, okay, if I track the function from the left side, I'm going to go, I was going up, 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 all the way up until this point. We call this point maximum point. And then the function starts, so it was increasing until it reached the maximum, and then it decreased, right? Until it reached this point, which is the minimum. And then again, increasing until this point, max, and then decreasing again until this point, minimum, again starts increasing again, okay? So increasing again, okay? So that's increasing. So what happened? The function was increasing from negative infinity all the way to this point, and this point was negative 3. So I can say the function is increasing from negative infinity to negative 3, negative infinity to negative 3. It was increasing until it reached the maximum point. At the maximum point, it was a maximum, so kind of stopped at a second. So I'm going to keep it open. I'm not going to include it. Union. It was increasing until it reached a maximum and then decreases. So it decreases from -3 all the way to -1. From -3 to -1, the function was decreasing. So decreasing -3 to -1. And then it increases again from -1 all the way to 1. And again, it will be always from the maximum and minimum points open interval. And then decreases from 1 all the way to 3. The behavior of the function was decreasing. So from 1 to 3, it was decreasing. And then finally increases from 3 all the way to infinity. That's the increasing and decreasing intervals. Okay, finally, we're going to look at the domain and range. Well, based on the graph you can see here, the function is, domain is representing x-axis, range is the y-axis. So we can look at the domain. Look at the function here was decreasing, right? So it covers all of this from the x-axis. Same here, this part from the x-axis has been covered by this function here, this part. And then this part has been covered by this. And finally, all of this, right? So if you notice, everything on the x-axis has been covered by something from the graph. So we're talking about -infinity to +infinity, or you can call it all real numbers. Okay, it's all real numbers. That's the domain. Now what about the range? Now by looking at the function again, let's look at the y-axis. By looking at the y-axis, you notice that it's going all the way up forever, so it covers all the way until +infinity. So all this part has been covered, okay? Same here, from both sides basically. Okay? Now what about down? Well, the function was going down to -infinity, so it covers also this part that we don't see the rest of the function, the graph. So also it covers all real number. I can consider it all real numbers. Okay, guys? Now, I just want to say that I'm asking you to write the intervals. However, you can write it as using the inequality. If I ask you for that, you can use the inequality. You can say, for example, here you can say x less than -3. For this one, x between -1 and 1. For this one, x greater than 3. You can use this instead of the interval. Okay? Let's try to find out the same thing for this function here. Okay? So first of all, we are going to look at the x-intercepts. In this case, x-intercepts are these points. So I'm going to call it x equal -1, comma, x equal 2. Someone will try to write it as ordered pairs. That's okay too. For the y-intercept, it's this point here in which the function, the graph, intersects with the y-axis, which is going to be y equal -4, or you can say 0, -4. Now we are going to look at the positive intervals and negative intervals. So look at the positive and negative intervals, you are going to look at the parts of the function that is above the x-axis. This part only above the x-axis. The rest is below. So I can start with the part that is above the x-axis from 2 to 4. Okay? So that's the positive from 2. I'm going to keep it again open interval because these points are x-intercepts. Now for the negative intervals is the part in which the graph is below the x-axis. We don't want to forget these points. The x-intercepts in which y is 0. So now for the x-axis, this is -infinity. So the function was going down, covering all of this from the x-axis, all of this from the y-axis. So because we are talking about the negative infinity, we're going to look at the x-axis. So it's going to be from negative infinity all the way to negative 1, then from negative 1 to 2, then 4 all the way to positive infinity, because the function, yes, it was decreasing when it comes to y, however, the x values were increasing. So it is going all the way to positive infinity. So negative infinity, so we're going to start by negative infinity to negative 1, union, negative 1 to 2, union, 4 to infinity. Now we are going to look at the the intervals of increase, intervals of decrease. So by looking here, we will notice that the function was increasing all the way, it reached this point. This is a maximum point. And then it starts decreasing until it reaches this point, minimum value, increases again until it reaches the 2. Again, it starts increasing until it reaches this point, and then decreases. Okay, I'm gonna say increase, decrease, increase, stopped here, and then increases again, and then decrease. Okay, there is some kind of stop here in which the function was kind of stop. So negative infinity all the way to 1 is increasing. So negative infinity to 1, the function was increasing, and then at this point we're not sure, it's not 0, it's something here. We can say 0.2 maybe. Look at the graph, guys, see, it is kind of here. Okay, so I'm gonna call it 0.2. So decreasing from 1 all the way to 0.2. Sorry, 1, negative 1 to 0.2, and then from 0.2 increases all the way to 2, and then again 2 to this point, 2 all the way to this point. It's not really clear what is the value here. I'm gonna just round it, so we are talking about something here, something like here. Okay, so let's say it's a bit more than 3.5. I'm gonna call it 3.6, okay, or 3.7. And then from 3.6 all the way to infinity, it was decreasing. Now let's look at the domain and range. So by looking at the function, it goes down here. That means it covers all of this in the x-axis. Same with this side here. Now about in between, it has been covered by this part. I'm talking about the x-axis. Same here, it has been covered by this function here, the part of the function. So it's basically all real numbers. That's the domain. Okay, so the domain is all real numbers, negative infinity to positive infinity. Now about the range. So by looking at the range is basically the y-axis. So in order to find the range, we're gonna try to find out how much has been covered from the y-axis. So by looking here, we notice that all of this from both sides, even going in, of course, to negative infinity. So all of this has been covered here in the, now everything from the negative. So from negative infinity to 0, everything has been covered. Now the other side, which is the positive y value. Okay, let's look at the positive y value. Looking at these, everything here, 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 until here. What about something above? What about this part here? Nothing. There's no graph on this part. So what we're going to say, it's negative infinity to 4. Remember, when it comes to interval, you have to mention the smallest first. So negative infinity to 4. So negative infinity to 4. Now I'm going to say whether I'm going to include or exclude 4. So basically, how do we know? If there is, okay, if there is an open interval here, open, that means 4 is not included, okay? Since it is not open interval, there's no open circle, so it's going to be a closed interval from negative infinity to 4. So guys, that's everything about functions. I hope you enjoy the lesson. Please let me know if you have any questions, and see you in the next video. Bye bye.